this one turns out to be an ellipse. But we have to complete the square twice on this one, so this one's going to be even tougher to complete the square. So I'm going to leave a little blank here, and then write plus 4y squared plus 8y plus blank equals 23. Alright, so I know this is a little tricky, but we got to pull out a 9 from here and make this x squared minus 2x plus something, plus, and we're going to pull out 4 from this one, making it y squared plus 2y plus something, still equals 23. Okay, so now we're going to complete the square. So we're going to add something right here to make this perfect square trinomial. That's something is b over 2 squared. So that's negative 2 over 2, which is negative 1 squared here, which is really just 1. But that 1 is going to get multiplied by this 9, and so I'm going to have to add 9 to the other side. Same thing here, 2 over 2 is 1 squared is 1, but it's going to get multiplied by 4, so I'm going to have to add 4 as well to the other side. Now this makes this a perfect square trinomial, so it makes it x minus 1 squared. This becomes y plus 1 squared, and this becomes 23 plus 9 plus 4, which is 36. Okay, now standard form for an ellipse, if you look at your formula sheet, is, I'm sorry, that's a parabola. It's equal to 1. So I need to get it equal to 1. So I'm going to divide through by 36 to everything to make sure that this equals 1. Alright, now this becomes, if I simplify, 9 goes into 36 4 times, so it becomes x minus 1 squared over 4 plus 4 goes into 36 9 times, so y plus 1 squared over 9 equals 1. So there's my standard form for an ellipse. I think that's all they wanted. Oh, they actually want the center, and then the length of the major axis and the length of the minor axis. So all that information is right here. I'll show you how to find it. First of all, the bigger number is underneath y in this case, so that's always a. A is always the length of the semi-major axis, which is half the length of the major axis. So in this case, a is underneath y. You can see, and that's what we have. We have the bigger number underneath y, the major semi-major axis. So that's written first in this form. So it's, I'll write it like this: minus 1 minus a negative 1 over 3 squared plus x minus 1 squared over 2 squared equals 1. Just so you can see that a is 3, which makes that's the length of the semi-major axis. So the major axis would be length 6. And then the center, you can see, is at hk, which is negative 1 comma 1. I'm sorry, h is the other way around. H is here, 1 comma negative 1. And then we have the major axis has length 6, and the minor axis has 2 times b, so b is right here, which is 2, so it'd be length 4. So you can even graph this and get a rough sketch of what this looks like. Has center 1, negative 1 right here. Major axis has, a is 3, so you go up 1, 2, 3, and then go down 1, 2, 3, and then b is 2, so it means you go over 2, and over 2, and then here's your ellipse. So if the major axis has length 6, the minor axis has length 4, and the center is at 1, negative 1. Okay, next problem, problem 7, says that a bridge underpass in the shape of an elliptical arch. So draw an ellipse, and imagine a road that goes through, and the road's going to be like basically the major axis. And then it says it's 40 feet wide, so I'm going to draw like another vertical axis, like the minor axis, so that I have like basically an x and y axis here. Now imagine the truck driving through like this. The question is, how high is the truck? Well, we have some distances here. We know that the whole thing's 40 here, so this would be 20, right from here to here. We also know that this would be 15 from here up to the top. And we also know that this is 4 right here, from here to here, because they told us the truck was 8 feet wide. So what we can do basically, if you look at this ordered pair goes over 4 up a certain height y, and we're trying to find that height y. So what we can do is write an equation for the ellipse and then find y. The equation for the ellipse on the formula sheet, if the the major axis is horizontal, is this formula right here. where y equals the number, because that's a horizontal focal axis. So that's x minus h squared, but this is centered at the origin. We purposely centered it at the origin in our formula so that we can have x squared over a squared plus y squared over b squared equals 1. And then a is the half the length of the major axis, which is 20. So my formula becomes x squared over 400 plus y squared over 15 squared, which is 225, equals 1. Now all we have to do is plug in 4 for x, so 4 goes in right here for this x, and then we can solve for this y. So if we do that, we get 16 over 400 plus y squared over 225 equals 1. Hopefully you guys can solve this. All you have to do is do 1 minus this number, and then multiply both sides by 225 and take the square root of both sides. And if you do that, you get y equals 14.697 about. And that answer works. Obviously, if the truck was actually 14.697, it would scrape. So really, we should safely say we should go with a height of 14 only, but Webwork accepted the 0.697, so that will work. Okay, the next problem is really easy. It gives us an equation for an ellipse, and it wants us to translate it to the centers of the origin. Well, if you remember the equation for ellipses, if you look at the formula sheet, it's in basically standard form, except for, standard form typically is like, we would write it like this, x minus 1 squared over 25. Usually we actually square these, so y plus 9 squared over 36 equals 1. And then you can see that h is 1 and k is 9. So this thing's been shifted over 1 and up 9, or down 9, or whatever. So we just have to put it back to the origin. So all we want is just to make h and k 0. So there's your answer right there. Just x minus 0 and y minus 0. So all you have to do is enter that in. Okay, the next problem wants to find an equation with ellipse with these properties. I usually draw a picture first because it helps me visualize what's going on. This thing has vertices at plus or minus 49, comma 0. So imagine way up here, 49, comma 0, and negative 49, comma 0. We have vertices, and then also at plus or minus 9, which we'll say is here and here. So this would be 9, comma 0, and negative 9, comma 0. So our ellipse looks like this. Okay, we know it's a vertical ellipse. We know A is 49 in this case because we go up 49 in this direction. We know B is the length of the semi-minor axis, which in this case is 9. So we have A and B. Our formula on our formula sheet tells us that we have a vertical ellipse, so we want to use this one, h equals or x equals a number, because that's the focal axis that goes vertical, so that's a vertical line, x equals a number. So we're using this formula right here, which is y minus k. Now, h and k are 0, so I'm just going to do y squared, it's centered at the origin, over a, which is 49, so this would be 49 squared, plus x squared over b, which is 9 squared, equals 1. So there's our answer, and we can square both these numbers and enter it in that way. Okay, so the next one says find the vertices on both sides of this. This is a hyperbola, so we're going to have to look at the hyperbola formulas in the formula sheet now. Now, hyperbolas are a little bit different. When the x term comes first, we are looking specifically at the left column here. So when the x terms come first, that means the focal axis is horizontal, so that means the hyperbola opens this way when the x term comes first. And when the y term comes first, it's going to open vertically. Okay, so we're looking at this column right here. We know that. So we have our formula, and we know then by comparing that h is 2 and k is 1. So here's our hk, or our center. I like to graph these just because I think it really helps visualize it. You don't necessarily have to graph it, but the center is at 2, comma 1, which is right here. Now, if you look at this, I would write this in a different form. So I'd write it as x minus 2 squared over 16 minus y minus 1 squared over 64, just because I'm used to writing it like that. And then a is 4, and b is underneath y in this case, which is 8. So what that means in terms of graphing a hyperbola is you go over 4 to the right, so 1, 2, 3, 4, and you put your first vertice, and you go over 4 to the left, 1, 2, 3, 4, and put your other vertice. And then if you go up 8 from here, so you go up 8 to this point and down 8 to this point, and you make a box, and then you graph the corners of the box with the lines, and those are asymptotes. those are your asymptotes that are actually right here in the last row. And so then you can draw your hyperbola like this. It goes through these vertices and goes. It's an asymptote, and these are the asymptotes. Okay, so when it wants us to find the foci and the vertices, we're looking at this part right here. The foci are at h plus or minus c, comma k. So in this case, our h is 2. So we have 2 plus or minus c, comma 1. So we need to find c. Now c comes from right here. C, we have a Pythagorean relation for these, which is that c squared, the relationship between a, b, and c is c squared equals a squared plus b squared in this case. So we have a squared is 16, b squared is 64. So that gives you c equals the square root of 80. So if we do plus or minus the square root of 80, that'll give us the foci. Now, it wants the small one first, so make sure when you enter these in, you do 2 minus the square root of 80, comma 1 first. And then you do 2 plus the square root of 80 second. Okay? And then it also wants us to find the vertices. So to find the vertices, you do h plus or minus a, comma k. So these are a little bit easier. You have h plus or minus a is 4, comma 1, comma k. So that'd be 2 plus or minus 4, comma 1, which do the small one first. So do negative 2, comma 1 first, which is this point here. And then do 6, comma 1, which is this point there, in that order. Okay, the next problem gives us standard form for a hyperbola. We know it's a hyperbola because it's got a minus sign here. And it tells us the center, hk, of this hyperbola, and it tells us the focus is at this point, one of the foci is at this point. And it also tells us one of the vertices. So I would always graph these because I feel like it really helps to look at a picture. And it helps organize the information. We know our brains are visual. So graph it if you can. 1, 2, 3, 4, 5, 6, 1, 2. So here's the center. And then one of the focuses at 11, 2. So here's 6, 7, 8, 9, 10, 11, 2. And then another one then, so the vertex is at 2, 2. So if one of the foci is at 11, 2, it turns out that this distance between the center and this focus right here is 5, from 6 to 11. So go back 5, 1, 2, 3, 4, 5, and put another foci. And then put the vertices, so one of them is at 2, 2, which is right here. So it turns out the vertice is 1 unit back from the foci, one of the foci, so put the vertice here. So we know what this hyperbola looks like. It looks something like this now. And that can help us. So from here, they want us to fill out the formula. So it's x minus 6 squared over a. Now, a is the distance from the center to one of the vertices, which in this case is 1, 2, 3, 4. So a is 4. And then it's y minus k is 2. And b now, we don't know b. b is actually the distance right here to the top of a box we're going to make later to graph these. But we don't know what that is, so we're going to find it using this Pythagorean relation right here on the formula sheet. That Pythagorean relation is c squared equals a squared plus b squared. We actually know c. c is the distance from the center to the focal point. So that's, we said that was 5. So 5 squared is 25. We know a is 4, so that'd be 16 equals b squared. So if we subtract 16, we get 9, and that makes b equal to 3. And so now we can fill this out. I wish they would use h for the c, but so not to confuse it with the c that is, the actual distance here. But they used it here, so c in this case is 6, a is 4, d is 2, and b is 3.